Hi, and welcome to another edition of Hacking Maths. Today, we're going to be looking at how to create equations with two unknowns. So, grab your pen and pencil and let's begin. So first off, let's start with some definitions. The first definition we're going to look at is sum. When a question asks sum, it really means the result of an addition. So sum means do an addition. Difference, or find the difference, is the result of a subtraction. So that means we would do a subtraction. Product is the result of a multiplication, so we multiply to get the product. And lastly, quotient is division, is a result of a division. We divide to get the quotient. So let's have a look at a few examples of this. What is the sum of 6 and 7? So sum is add. So what is the result of an addition of 6 and 7? The answer being 13. So the sum is 13. Now, what is the difference of 15 and 12? So, what is the subtraction of 15 and 12? The difference would be 3. 15 take away 12. What is the product of 4 and 5? 4 times 5, 20. The product is 20. What is the quotient of 50 and 5? Normally we divide the first one by the second, so 50 divided by 5 would be 10. And 10 is the quotient. So, let's have a look at an example. Let's take a look at this. Two numbers have a sum of 15. So what numbers could they be? Now, it's quite easy to produce a list of all the numbers we could think of, and I've done so. However, these are only positive numbers. Couldn't I also have negative numbers that make 15? Like -1 and 16? Or couldn't I even have fractions? A half plus 14 and a half? So really, these are only the positive integer solutions that I've written. And that if we bring negatives and we bring fractions into it, we could have an unlimited, in fact, an infinite number of possible solutions to this. So in maths, that poses quite a problem. So we need to start to break this down. And the first thing that we should do is write an equation. Now in maths, when we don't know something, we give it a letter. And as we've got two numbers, we'll give the first number and we'll call it x. And maybe we don't know what the other number is. It could be the same as the first, but I imagine it's probably different. We could call that y. And as the question says sum means add. So if we add these things together, x plus y should give us a total of 15. And there we've written down our first equation using two unknowns. So let's have a look at another situation where we could have two unknowns in an equation. Here it says 2 burgers and 3 Cokes cost $12. So 2 burgers, 3 Cokes cost $12. Now we need to give some letters here. So we have 2 burgers, so perhaps B for the cost of a burger. And we have 2 burgers, so that would be 2B. How about losing the letter C for the cost of a Coke? And we have 3 Cokes, that would be 3C. And then if we total all this cost together, it should equal $12. Now this is the thing we have to really pay attention to, is what these letters stand for. If you notice, I said that B stands for the cost of a burger. And 2 stands for the 2 burgers that we have. C stands for the cost of a Coke. And 3 stands for the 3 Cokes that we have. If we add the total cost, it should come to be $12. And remember then, so for this, B is the cost of a burger, C is cost of a Coke. Let's take a look at another example. A group of people go to the cinema. They buy 5 adult tickets and 3 child tickets, and it costs $68. So 5 adult tickets, 3 child tickets, and the total of that is $68. So if we say that the cost of 1 adult ticket is A, the cost of 5 adult tickets will be 5A. If the cost of 1 child ticket is C, the cost of 3 child tickets will be 3C. And then the total cost of 5 adult tickets and 3 child tickets, when we add them together, must be 68. Now, remember that the A in this stands for the cost of an adult ticket, and the C stands for the cost of a child ticket. And so, when we work this out, we're working out the total cost. Let's have a look at another example. Now, this is a very common simultaneous equation problem that requires you to construct 2 equations. Now, today, we're not going to solve this problem, but what we're going to do is construct the equations that allow us to solve the problem. So first of all, we need to find out what our variables are going to be counting. So let's start with the first thing. A theatre sells 300 tickets. Now, they sell 2 types of tickets. They sell adult tickets and they sell child tickets. Now, how many adult tickets did they sell? And how many child tickets did we sell? Can we say? Well, if we say that A is the number of adult tickets sold and C is the number of child tickets sold, then A plus C must equal 300. So that gives us an equation there. A being the number of adult tickets sold and C being the number of child tickets sold. So let's see if we can come up with a second equation. We've dealt with the number of tickets, let's deal with the cost. So, they have adult tickets at $10 and they have child tickets at $5. Well, how many adult tickets did they sell? They sold A. It says right here at the bottom, A equals the number of adult tickets sold. So if they sold 1 ticket, they make $10. If they sold 2 adult tickets, it'd be $20. If they sold 3 adult tickets, it'd be $30. So if they say A adult tickets, it will be 10 times A. So 10A. So 10A is the total money from adults. They also have child tickets at $5. And we said that C is the number of child tickets sold. If they sold 1 child ticket, they get $5, 1 times 5. If they sold 2 child tickets, they would get 2 times 5, which would be $10. They sold 3 child tickets, 3 times 5, so that would be $5. But they're selling C child tickets, so that would be 5 times C, which would be 5C. And that would be the total money from children. Now, if we took the total money from the adults and we added the total to the total money from the children, we would get the total money taken. And if we remember the question, the total money taken was $2,500. So let's quickly recap what we've found out. So a theatre sells 300 tickets. That meant we came up with an equation that worked out the total number of adult tickets plus the total number of children tickets, and that said it was 300. We then worked out an equation for the cost. So we said that there was the cost of $10 for an adult ticket, so 10 times the number of adult tickets, plus 5, the cost of a child ticket, times the number of child tickets would equal 2,500. Now that we've got to this, it's actually possible to solve it and find out how many adult tickets there were and how many child tickets there were. However, that's for another lesson, and that's all we've got time for today on Hacking Maths. I hope to see you next time.